Now we will see how to do correlational analysis in SPSS. For that, I would like you to open the exam anxiety file that you are already familiar with and click on Analyze, and here you can see a list of tests that you can run. From this you choose Correlate, and as you can see it's very straightforward. We've got bivariate and partial. So you choose bivariate, and the bivariate correlation window opens up. On the left side of the box you can see all your variables listed. So if you remember the study, we've got an interval variable, time spent on revising before the exam. The second interval variable is exam performance. The third variable is exam anxiety, and we also have a variable of biological sex that we are going to ignore now. So you can drag your variables that you would like to correlate to the variables box with the help of the arrow. And there are three different correlations coefficients that you can calculate. The Pearson correlation coefficient has to meet several assumptions before running the analysis. In Pearson's correlation, all your variables have to be measured on an interval scale, so it should be interval data. As you can see here, this is interval data. For the Spearman coefficient, correlational coefficient, you have non-normally distributed data, and also it can be other than interval data, for example, ordinal data, a position in a context. You are first, second, third. And we very rarely use the Kendall tau. Okay, for this statistical analysis, we will choose the Pearson. The test of significance also has two options, two-tailed or one-tailed. You choose one-tailed test when you have a directional hypothesis about your variables, how you think they are related. For example, here we think that the more anxious someone is about the exam, the worse their mark will be. Okay, so the more anxious you are, the worse you will perform on the test. Or the more time you spend on revising, the better you will perform on the test. You choose a two-tailed hypothesis or a two-tailed test when you have no directional hypothesis, so you cannot predict the relationship or the direction of the relationship. Okay, here we choose the one-tailed, and this is all we have to do. So you put your variables to the variables box. You choose the correlation coefficient based on your data, on your variables. If it's normally distributed and interval data, it will be Pearson correlation. If it's not, it's Spearman correlation. Depending on your hypothesis, you choose two-tailed or one-tailed. And you click on OK. And here you can see the outcome of your analysis. So the first line always represents the strength of the correlation between the variables. So time spent on revising positively correlates with exam performance because it's positive and significant. It is flagged by these asterisks, so correlation is significant at 0.01 level. Then it means the more time you spend on revising, the better you perform on an exam. And this relationship is significant, and n is the number of participants. The time spent on revising negatively correlates with exam anxiety, which means the more time you spend on revising before the exam, the less anxious you are. Exam performance negatively correlates with exam anxiety, which means the more anxious you are, the worse or the less scores you have on the exam. Okay, so here you have a negative correlation between exam performance and exam anxiety. It's a significant correlation. How do you report on this? This is how. So exam performance was significantly correlated with exam anxiety. The correlation coefficient is a small r, it's negative, and time spent revising, yeah, also significantly correlated, and the time spent revising was also correlated with exam anxiety, and you can see this is a very strong correlation, and all p's, which is probability, the significance was smaller than 0.0005005. What you can also calculate is the r squared. So if you think about exam performance, then there are a lot of factors that can play a part. Motivation, your mood, your circadian rhythm, even your gender, the time of the day, etc. So we would like to see how much of the variation is explained by exam anxiety. We could see that there was a strong negative correlation between exam anxiety and exam performance, but we would like to see how much does it contribute to exam performance. So for that we can use the r squared, which is the coefficient of determination. So what you do is you take the correlation coefficient between exam performance and exam anxiety, you square it, and the result will be 0.194, and if you put it into percentage, you have to multiply it by 100, it will be 19.4%. What does this mean? This means that although anxiety was highly correlated with exam performance, it can account for only 19.4% of variation in exam scores. So there is still 80.6% of the variability still to be accounted for by other variables. Using the same method, squaring the correlation, you can calculate how much variability in exam performance is accounted for by the time spent revising. So you have to square this number and multiply it with 100, and you can also do the same with the time spent revising with exam anxiety. So you have to square this number and multiply it by 100. Okay, this is the Pearson correlation. The second one is this was the Pearson, and then the Spearman correlation. For this, I would like you to open another data set, the biggest liar. Fine, okay, so here you can see that we have 3 variables, but we will ignore the third. 2 variables. So in England, there is a competition organized each year. It is the biggest liar competition, where people are expected to tell tales including big lies that people believe. And a scientist was interested whether creativity has anything to do with the position that people win. So whether more creative people win the first position, or creativity has nothing to do with the position. So since we have an interval data and an ordinal data, because the data is ranked, we use the Spearman correlation. So again, you go to bivariate, you have these two variables, you choose the Spearman, and we have a hypothesis. We think that the more creative you are, the better position you get. So you correlate, and you can see this is a non-parametric correlation because we have non-parametric data, and what you can see that there is a significant negative correlation between creativity and the position in Biggest Liar competition. So the more creative you are, then the better position you get. Why is this negative? Because the better, if the creativity increases, then the position decreases. But remember, the smaller the number you have in the position, the better you are. If you have the first place, so place 1 is better than place 4. That's why the negative relationship. So creativity, with the increase of the creativity, you have more success in competition. How do you report on this? Creativity was significantly related to how well people did in the world's Biggest Liar competition. R equals minus 0.37. Remember, we don't use zeros, and P is smaller than 0.005. So it's significant. Another way of doing correlations is to use dichotomous data. Dichotomous data has only two categories. For example, someone can be pregnant or non-pregnant. Non-pregnant, there is no between. So this is what we mean by dichotomous data. Or someone can be male or female, but there is nothing in between. So for this kind of analysis, when you have a dichotomous data, you choose the PB core data set. And here you can see that we have two variables. A scientist was interested whether the gender of a cat, whether it's a male or a female, has anything to do the time spent away from home. So what he did, he went to his friends, asked the gender of the cat, whether it was a female, which is 0 in our case, and male, which is 1 in our case, and he asked how many hours the cat spent away in a week, approximately. Okay, so there are always two codes, 0 and 1. These are the two codes you always have to use. And you have a directional hypothesis. So you think that if you are a male, you spend more hours away from the home because you date other cats. There is a scale and a nominal variable. So what you do is you go to correlate bivariate, and here you again use the Pearson correlation. And we have a one-tailed hypothesis because we think that males spend more time away. What you see here is that we were right. There is a positive correlation between the time spent away from home and the gender of the cat. If you change the coding scheme in the file, so you would put 1 for female and 0 for male, then this number would be negative. So it would mean the same, but in a reverse order. The last correlation that we do is partial correlation. So we had bivariate correlation and the partial correlation when we correlate two variables controlling for a third variable. Remember the study about exam performance, exam anxiety, and time spent on revision. So you know how to calculate the percentage a variable accounts for variation in another. So for the shared variation. And we could see that exam anxiety accounts for 19.4% of variance in exam performance. Then at revision time, if you calculated this, accounts for 15.7 variation in exam performance. If you put these together, then it's more than 50%. So there is a shared area here, and there are areas which are not shared. What we would like to see is the unique relationship between exam performance and exam anxiety, because at the moment we only see these three being put together. Okay, so if you remove the portion of variation that is also shared by revision, so if we remove this portion, then we get a measure of unique relationship between exam performance and exam anxiety. And if you have several variables, it is a very wise thing to do. So let's look at our data set. Here we are, and you go to partial analysis, and I already put my variables here. So you would like to see the correlation between exam performance and exam anxiety, controlling for time spent on revising. We've got we actually have a hypothesis that the more anxious you are, the worse you perform on an exam. And okay, here you are with the results. So remember, previously we had a result of minus 0.441, which was around 19.4% of the variation, so 441. And now if we take revision out of the equation, then you will see minus 0.247, a significant correlation between the two, negative, but it's the half of the correlation, so the relationship almost diminishes. And if you correlate the r square, so if you square this number, then you will get a number of 6, which is 6%. So you can see that now we have a clearer picture that exam anxiety accounts for even less in exam performance. And how do you report on correlation? There are 5 rules to keep in mind. There should be no zero before the decimal point for the correlation coefficient or the probability value, so that's why we always say that 0.76 or 0.441. Okay, we use no decimal points. Coefficients are reported to do 2 decimal places and not more. If you are quoting a one-tailed probability, you should say so. So you always have to say it was a one-tailed or a two-tailed analysis. Each correlation coefficient is represented by a different letter. You can look it up on the internet, and there are standard criteria of probabilities that we use. So for example, P was smaller than 0.05, P was smaller than 0.01. For example, there was a significant relationship between the numbers of adverts watched and the number of packets of sweets purchased. Remember our first example. So correlation coefficient, Pearson's correlation coefficient equals 0.87. Okay, 2 decimals and no zeros before. And P, probability one-tailed, is smaller than 0.05. And you are familiar with the rest of it. Okay, that's it about correlations.